Hey cosmic commuters, get ready to strap in and warp through the fabric of space-time itself. Today, we're ditching the interstellar highway and diving headfirst into cosmic time travel. Are you ready to explore the past and future of our mind-boggling universe? Hold tight, science is getting wild. Now hold on, I get it. Time travel usually means flying DeLoreans, timey-wimey shenanigans, and paradoxes that make your head hurt. But get this, the universe has its own way of warping the rules of time, and the science behind it will make your jaw drop. Let's talk Einstein and the mind-bending nature of reality. Busting the time travel myth. We're used to time being this absolute thing, like the steady ticking of a clock. Turns out that's an illusion. Thanks to Einstein and his revolutionary theories of relativity, we learned that time isn't fixed. It's relative, meaning it changes depending on how you're moving and the forces you're experiencing. Einstein's special relativity blew our minds. It revealed two game changers. The speed of light is king. The speed of light, roughly 186,282 miles per second, is like the cosmic speed limit. Nothing can go faster, and this fact has weird consequences for time. No universal and now. There's no single present moment across the universe. What's now for you might be in the past or future for someone zipping by at a crazy speed. It's all relative to the observer. If you thought time being relative was weird, brace yourself. Gravity, the force that keeps us stuck to this big blue marble, is the true heavyweight champion of time manipulation. Let's dive into how gravity messes with the flow of time. Space-time, not just empty space. Einstein didn't just revolutionize our understanding of time. He smashed our idea of space as well. Picture space not as a flat stage, but a stretchy fabric, something called space-time. Massive objects like stars, planets, and especially those monstrous black holes warp this fabric. The stronger the gravity, the more extreme the curvature of space-time. Time warps with gravity. Now here's the kicker. This curvature of space-time affects time itself. Imagine placing a clock deep in a gravity well, like near a black hole, and one far away in weaker gravity. The clock near the black hole would tick slower, and I mean noticeably slower, than the one farther out. It's like gravity stretches and slows down time. Real-world trippy time travel. This isn't just theoretical. Astronauts on the ISS experience slightly weaker gravity than us here on Earth. Their clocks actually run a tiny bit faster than ours down here. They're literally aging a fraction of a second slower. Proof that cosmic time travel happens every single day. We've talked about how gravity can slow down time, but now let's shift gears and see how speed can stretch it out. This is where things get wild thanks to something called time dilation. Special relativity round 2. Remember Einstein and his special theory of relativity? Well, it has another trick up its sleeve. Not only is the speed of light constant for everyone, but as you approach it, time starts playing some funky tricks. The faster you go, the slower time flows. Imagine this. You've got a twin who's a couch potato. You, on the other hand, hop on a spaceship and blast off at a significant chunk of the speed of light. While you're cruising and enjoying those awesome zero-G snacks, time for you would tick along normally. But if you checked back with your twin on Earth, years, maybe even decades would have passed for them. It's all about the reference frame. Here's where things get a little trippy. From your perspective on the spaceship, it's like time for everyone back on Earth sped up. Both of you would perceive the other as aging slower. It's that relativity thing again. There's no single absolute frame of reference. Time travel to the future. So, while we haven't figured out how to rewind the clock, high-speed travel is essentially a one-way ticket to the future. The closer you get to the speed of light, the more pronounced this time-stretching effect becomes. If we ever develop spacecraft capable of those kinds of speeds, astronauts could return to Earth having aged far less than those who stayed behind. We've seen how gravity and speed can warp time, but now let's get really speculative. Wormholes, if they exist, could be the ultimate cheat codes for cosmic travel, potentially allowing us to cheat both distance and time. Einstein-Rosen bridges. The idea of wormholes pops right out of Einstein's general theory of relativity. Picture space-time, that flexible fabric we talked about. Theoretically, it could be folded in a way that connects two super distant points, creating a sort of tunnel or bridge through space-time. These are often called Einstein-Rosen bridges, cosmic highways. Imagine the universe as a giant sheet of paper. To get from one end to the other, you'd usually have to travel the whole distance, but with a wormhole, you could fold the paper, punching a hole to the other side. Voila! A shortcut across mind-boggling distances. Time travel possibilities. Now here's where wormholes start really messing with our heads, because they connect not only points in space, but also points in time. You could theoretically step into one and emerge somewhere else in the universe at a different point in its history. The possibilities are both tantalizing and terrifying. The sticky wicket of wormholes. Of course, this is all highly theoretical. Big questions remain. Do they even exist? We've never observed a wormhole, and many physicists suspect the universe wouldn't like them anyway. They might be incredibly unstable, collapsing as soon as they try to form. Can we make one? If wormholes do exist naturally, they might be on tiny scales, requiring mind-boggling amounts of energy to open and stabilize them for actual travel. Surviving the trip, even if we do open a stable, usable wormhole, the forces inside might be, well, a tad on the crushingly destructive side. So, while wormholes remain mostly in the realm of science fiction, they keep scientists and science fiction writers alike dreaming. Who knows, maybe one day the idea of shortcuts through space-time will become a reality. Okay, let's get down to the biggest, hairiest question of them all, traveling backward in time. While physicists love a good mind-bending problem, this is the one that triggers those existential headaches. Here's why. Causality conundrums. Our universe has this fundamental rule called causality. Causes always come before effects. You stub your toe because you kicked the table leg. Things don't happen in reverse. But if you could go back in time, causality starts to fall apart. The grandfather paradox. Here's the ultimate brain twister. The infamous grandfather paradox. What if you traveled back in time and prevented your grandparents from ever meeting? Well, then your parents would never have been born, and neither would you. But if you don't exist, how did you go back in time to do this in the first place? The universe hates these kinds of contradictions, unraveling possibilities, solutions, or illusions. Physicists and philosophers have proposed some super trippy ways to maybe get around these paradoxes. Multiple universes, maybe every time you go back and change the past, you split off a whole new parallel universe where that change exists. The original timeline stays safe. Self-consistency. The universe may have a bizarre way of self-correcting to prevent paradoxes. Even if you try to change the past, things might twist and turn, so events somehow still lead to the moment you traveled back in time. Essentially, what's happened happened. The verdict. While it's fun to think about, most physicists lean towards the sad but probably more likely conclusion. Traveling backward in time may be fundamentally impossible. The laws of the universe seem pretty determined to keep causality intact, no matter how much we want to rewrite history. So, while building a time machine in your garage is probably out, the universe itself is a giant, mind-bending time traveler's playground. Will we ever master it like in the movies? Who knows? That's the fun part of science. The possibilities keep expanding just like the universe itself. If you're hungry for more cosmic mind-benders, smash that like button and subscribe to the Cosmic Commute. Until next time, keep looking up.